Welcome to the Journey Chez Cam. Well, today we are going to discuss the lab. And I have 2 questions for you that are going to help you with that. So please do them to the best of your ability, and we'll discuss them in a moment. Number 1 is very similar to what one of the questions is in the lab. Well, in this question, we are given that there are 2.50 grams of the copper 2 sulfate, and the question asks what will be left of the zinc. Therefore, I know that zinc is in excess. So I must change my grams of my copper 2 sulfate and find out just how much zinc would be required to use up all of this 2.50 grams. Well, 1 mole of the copper 2 sulfate, and we're using the last equation given in the lab, which is a single displacement, and copper here has a mass of 63.6, sulfur is 32.1, and there are 4 oxygens, which is 4 times 16.0. And therefore, we have 63.6, 32.1, and 64.0. And when I add these numbers up, I get 159.7 grams per mole. And that gets me to moles. And then I must change to zinc. This is a mass type of problem. Well, 1 mole of zinc to every 1 mole of the copper 2 sulfate. And then I go back to my grams to find out how much I needed to use. And the AMU here for zinc is 65.4 grams of zinc for every 1 mole of zinc. And that's merely the AMU from the periodic chart. And when I do this math, I get 1.0237 grams. Now, the number that we're given here in the problem is 3 significant digits and to the hundredths place. And therefore, I'm going to use this to the hundredths place. This is what will be required of the zinc, and this is what I have. And therefore, I'm going to take the 4.50 grams and subtract 1.02 grams, and I will get 3.48 grams of zinc left over. And that's how you do that problem. In number 2, this is preparation for the next topic, as well as it is required for you to understand when we're talking about solutions. Well, here we are given 12.6 grams of tin 4 phosphate. And therefore, the tin has a +4 charge, and phosphate is -3. And we must always write the formulas correctly. Well, the common multiple between 4 and 3, the lowest common multiple is 12. And therefore, I need 3 tins and 4 phosphates. That is a big compound. Well, then I'm going to need the AMU in order to change it to moles. And I need to get molarity because it's asking for the concentration. And there are 3 tins, and each tin has a mass of 118.2. That's pretty heavy. And we have 4 phosphorus, which is 4 times 31. And we have 16 oxygens, which is 16 times 16.0. And I multiply them out again, and I get 356.1 and 124 and 256. And I add the total AMUs, and I get 736.1 grams per mole here. That's very, very heavy. Now, I will put this on the bottom so that my grams cancel. And when I do the math here, I get 0.01711 moles, and I need molarity. So I'm going to divide it by the volume of the solution, which is 150 milliliters, and I'm going to change that to liters because milliliters, because molarity is moles per liter of solution. And when I do this, I get 0.1140. Now we know this is not the final answer, but my answer that I'm going to use to find the other ions. And therefore I want two significant digits. And that is the molarity of the tin for phosphate. And then I'm going to see when I put this in water, it is going to dissociate. And I'm going to get 3 tin plus 4 ions and 4 phosphate ions. And it's very important to write the charge there, or else they're not ions. Without their charges, they'll look like compounds. We don't want to do that. So here I have a 0.11 molar solution, and here I have 3 times that amount, which is 0.33 molar and 0.44 molar. And remember, when you take one big thing apart and you get the individual parts, you're going to have a lot more parts than you had of the individual original substance. And we must always have the charges. Now, there are some solubility issues here, but as far as we're concerned, all salts will dissociate 100%. And so we're just going with that. And that's how you do number 2. Now we're going to discuss some things on the lab, and I will be right back. Labs are so much fun, and we learn so much when we're doing the labs. Well, many of the answers to the questions in the lab about the procedure I answered as I was going through the lab. Therefore, you may need to go back and watch the movie again to pick up some of those things to answer those questions. Now, it asks for 6 different ways to separate materials, and 5 of them are given in the lab. And the 6th one is precipitation. We use a lot of precipitation in this lab. And then in the discussion, many of the answers are also given to you. And a reaction will be complete when one of the parts of the reaction is removed or you use it up. And that is also in the discussion. Now, I want to talk about one of the problems where it's asking for the percent that's recovered. And it's given a problem where you are given that a student or someone obtained approximately 1.25 grams. Now, I've changed these numbers, so the process is going to be the same. And they started with 0.50 grams. And these numbers definitely are different than the ones in the lab, but the process will be the same. So I need to know what their percent yield is of this copper 2 nitrate. And therefore, I'm going to take my 0.5 grams of the copper and find out theoretically how much of this copper 2 nitrate should be able to be formed. And I'm going to change my grams to moles. This is a mass, lots of mass in this lab. And 1 mole of copper has a mass of 63.6 grams of copper. Now I'm looking for the copper 2 nitrate. And there's 1 mole of copper 2 nitrate for every 1 mole of copper. And then I need the AMU in order to go back to grams. Well, copper, as we said here, has a mass of 63.6. And there are 2 nitrogens, which is 2 times 14.0. And there are 6 oxygens, which is 6 times 16.0. And then I do the numbers again. And 6 times 16 is 96. And I add them up, and I get 187.6 grams per mole. And because I'm looking for grams, that goes in the top of the copper 2 nitrate in 1 mole of copper 2 nitrate. And that gives me 1.4748 grams of the copper 2 nitrate that should have been able theoretically to be made. Now, this student only got 1.25. Therefore, I take the amount that was recovered over the amount that theoretically I should have been able to get, and I'm going to be consistent here and use it to the hundredths because that's what I'm limited to in that problem, times 100, and we get an 85.0% recovery that was made by that individual. So remember, this is the process. The numbers are a little bit different so that you can work them out and not just copy the work. Because I want you to learn how to do this. And I know you can do it. We've been doing this for a long time. Now, the other things in the lab, I believe everything is discussed in the discussions, and the questions in the lab, you can go back and watch the movies again. It was a lot of fun. Well, thanks for being here, and I hope that answers all the questions that you have on the lab. And I can't wait to see you tomorrow. Bye.